On this episode of the Decision Intelligence Lab podcast, we welcome Harley Davis, founder and CEO of Athena Decision Systems. For anyone interested in how optimization, business rules, and simulation can be combined with generative AI to create real business value, you won't want to miss this episode. Harley is a veteran of the decision intelligence world who's played senior roles at iLog and IBM. And what he's doing at Athena is very much on the leading edge of combining traditional operations research and data science techniques with generative AI to effectively solve complex problems.
There's always technical challenges, and when you're trying to deploy LLMs at scale, there's a big performance challenge. And so there's definitely a scalability problem in using LLMs when you need to make sure that you get an answer back with only 2 seconds. So how do you structure the prompts? What kind of information are you looking for? Where do you put the LLM and how do you call it? And then there's other issues, very, very common that we see around things like privacy and security.
Hello, everyone. Welcome to the podcast. Our guest today is Harley Davis. So I've known Harley for a long time. He's an expert in business rules. He's had a long career at iLog and IBM. And at one point, his company acquired my company, and Harley was my boss for some period of time. So welcome to the show, Harley.
Hey,
Yeah,
Mike, how you
welcome,
doing?
Harley.
Hi, Vijay.
I'd like to start out. So we talked about your, long career in business rules. You recently at IBM for a long time, and then you just decided to, with the rise of LLMs, you decided to start your own company, Athena. So, what opportunity did you see, and what were you trying to do with this?
Yeah, so everybody's talking about generative AI right now, and obviously it's very exciting, and ChatGPT made it so that everyone could see the potential power of what LLMs can bring to the table in terms of natural language understanding and generation. But it seemed pretty clear based on the technology and based on a few simple examples that while LLMs are absolutely great for uh, generating natural language, understanding natural language, basically doing all sorts of interesting things around language, they don't really have inherent reasoning capabilities. What they do that looks like reasoning, pretty much comes down to very, very sophisticated pattern matching, but they don't do any kind of real deductive logic. And when you look at enterprise applications, when you want to take serious decisions, whether, in regulated industries where you have to worry about compliance, auditing, explainability, traceability of decisions that are made, LLMs were not going to really be up to snuff. Whereas business rules, the area that I've been in, and optimization, the area that we've both been in, it's
Right.
for a long time. Those are both, real techniques for coming up with real answers to questions that use reliable algorithms and symbolic understanding of constraints and rules. And so it seemed like there was a real opportunity to bring these two approaches together. Generative AI for understanding what people are saying and be able to express what you're trying to accomplish or be able to leverage information from customers or from documents in a very clear way, but then using these symbolic techniques like business rules to make good decisions that could be audited, explained, and would be reliable. And
Yep.
so I felt like that's where the puck would inevitably go in this game.
Yeah.
People are doing a lot of things now using LLMs for creative language generation or doing, applications around RAG, whether you try to chat with your documents. But inevitably, people would want to put these systems in their core business applications. And for that, we needed a different approach. We needed to combine LLMs with a different approach. So the reason I started Athena was to kind of leverage that potential and get to where the puck was going before it got there.
Perfect. One thing I've always been fascinated by your career is I think with business rules, you've always worked on really mission critical kind of applications for
Yeah.
companies that just can't go wrong. And I think you brought that thinking to LLMs when I read some of your early stuff. Can you just take a step back and talk to the audience, what it is about business rules that make them work in those mission critical systems where, an LLM might fail?
Yeah. Well, so let's step back. The first big use case for business rules, at least the first one that got iLog kicked off in this in this world was doing um, loan approvals. And in particular, there was a big case at Fannie Mae where they have like 11 volumes worth of loan approval rules, and they were given out to all the banks, and the loan officers in the banks would spend weeks poring over these documents and your application, and after a while, they'd come back with a yes or no answer. And then Fannie Mae would buy the loans from the secondary market based on, whether they were approved as prime mortgages or not, and they wanted to automate this process. And because the complexity and the frequency of changes to the rules and what made up a prime mortgage was very, very high, they needed an approach that wasn't just, translating all of those 11 volumes into code or complicated SQL queries that no one could understand. So they used a business rules platform for that. And that kind of spread out to the rest of the mortgage industry, and then from there into all the other industries like insurance and in industry and all sorts of areas. So in all of these cases, you can't really afford to make a mistake. If you start approving loans that shouldn't be approved, it can ruin your credit rating on the secondary market. It can introduce unreasonable risk into the bank. And from a consumer side, you don't want to be denying loans to people who need them. That obviously has consequences as well. In all sorts of areas, the same thing applies. Business rules, because they're a clear statement of, if this, then that.
Yeah.
It's more sophisticated than that, but that's the
Right.
simple version. Then you know that once you've got the rules written down, tested, you can audit them. The business people who are in charge of the policies behind the rules can audit the rules as well. You know that what you're getting is the right answer.
So, Harley, one thing that I have heard, but I'd love to get your sense of it as well, is that they also have the advantage of performing really well in terms of speed and ability to put
Very
them into
true.
real-time systems. Can you share a little bit about that?
Yeah, because the rules are, well, there's different algorithms for processing rules, but for the easiest case where you just have a bunch of if-then rules that you want to apply to transactions one by one, they can be extraordinarily efficient. In fact, in a lot of cases, they can be more efficient than handwritten code because we can apply a lot of optimizations to how they're processed based on analyzing the format of the rules, sharing common conditions and things like that that make it very efficient to the point where, the business rules are used in some of the most demanding applications out there. For example, they're used by several major payment platforms, such as PayPal, where you have a very, very narrow window of time to decide whether or not you're going to approve a transaction. And not approving a transaction basically means analyzing all the possible fraud cases and deciding whether the transaction, is legitimate or whether it's probably a fraud. And you basically only have tens of milliseconds to make that determination, or you simply have to approve it by default. So yeah, business rules have always been used in these high performance applications. There's cases in insurance industries, for example, healthcare insurance, where you're trying to process really, not only thousands and thousands of claims per day, but each one of the claims has thousands of line items that come from all the different tests or procedures that might have been used to generate the claim. And again, you have only a small amount of time if you want to get through all the claims in a reasonable time. Obviously, that's in contrast to LLMs, where even if they were to give a good answer, which, they don't in a lot of these cases, but
Yeah.
even if they did, the cost and the performance implications of running the LLMs on those use cases is, we all know what it's like when you run the model like, O1 or even worse, O3, to try to get some reasoning done. It generates, thousands of tokens and it calls itself recursively, so it gets, the performance is not great.
So, um, I got to jump on this term from your recent paper. You've described LLMs as stochastic parrots, which brought a smile to my face. Can you elaborate on that a little bit and so kind of talk about some of the risks and limitations that you've seen in terms of performance?
Sure. So obviously I didn't invent the term stochastic parrot. That came out pretty quickly after LLMs came out when people were trying to describe what they did. But I like the term stochastic because LLMs use, probabilistic statistical techniques to decide what the likely next best token in a sequence should be. The way LLMs work at the base is they figure out what the n most likely next tokens are, each one assigned a probability, and then based on that probability distribution, you choose one of them from that list. And so you go on and on. So it's really a stochastic technology at its heart, not a reasoning technology. Parrot, because it was trained on gigabytes or terabytes or petabytes of data from
Yeah.
the internet, and like parrots, it's spitting out what it heard. Obviously parrots don't hear petabytes of sound, but LLMs do, and so it basically spits out what it heard, reprocessed with a very complex, pattern matching capability based on a hugely multidimensional vector of similarity between all of the different sequences of tokens and words that it heard. So it's much more sophisticated than just repeating verbatim what it heard before, but still in the end of the day, it's leveraging past data to come up with current results. And that has an inherent limitation compared to what I would call a real deductive reasoning technology like business rules or optimization or logic programming or constraint programming, where basically define a search space, a formal search space where the answers, have to be in that space. And then you have some algorithm to go through the search space to find an acceptable or an optimal answer within that space. And you're doing some kind of search. That to me, that's reasoning. And
Yeah.
it's not exactly what people do, but people can do it if they need to in order to come up with an absolutely correct answer to a problem, whereas LLMs can't do that at all. You can try to push them to do it, but they never really do because it's not in their nature.
Let's come back to your mission at Athena and sort of what you
Sure.
guys are trying to do to bring LLMs together. Like where LLMs fit in your mind in that process? You describe business rules as being very
Sure.
robust, very helpful. Like how do LLMs sort of fit in and help that process?
So there's a number of different ways. The most basic way is that a lot of information that we want to make decisions about comes in the form of text or images, but let's say text.
Yeah.
And for example, you write an email as a customer to your service provider, and you say, this is the situation that I'm in, and you provide some data in that email, and then currently somebody has to read the email to figure out what to do about your case. Well, because you put a bunch of information in your email, and because, based on who you are and so on, you can access other information out of databases, an LLM can be very helpful in parsing that text, extracting the key data, leveraging other data sources that might be relevant, and then feeding the extracted data into a decision service. That's one way.
Okay.
There's other ways as well. For example, once you have a decisioning platform, for example, an optimization system, you may want to describe different scenarios that you want to test out. So you might want to say something like, what happens if I close my plant in China? How does that impact my production schedule? Well, today, with most decisioning platforms, if you want to do that, you have to interact with some complicated user interface to change some variables, change your model input parameters. Using LLMs, you can describe that kind of thing in a much more informal, natural way and still get the LLM to generate what it needs to do to modify the model or the input data to generate a good answer. That's another way. There's many other ways as well. But this is there's so much information and so many things that people want to do in natural language that, it seems like a natural thing to want to bring all that information to bear, and LLMs are a fantastic tool for that.
What are the challenges of integrating um, deterministic tools with a probabilistic tool like an LLM? And are there challenges with scale? Are there challenges with integration? What are you bumping into? What are you seeing that surprised you negatively or positively?
The technical challenges, I would say, what we're doing is some form of agent, what's now called agentic
Yes.
architecture or agentic solutions. I find the term a bit weird, but let's go with it. Um, so I think a lot of people who are doing AI or LLM-based solutions are basically trying to do the same thing. You have a bunch of interacting agents, each of which solves a small bit of the problem, and you try to link them together, and you have to link the agents with external tools using something like tool calling. And that requires, understanding when in the processing that you're trying to do, you need to call out to an external service. In our case, that's often a business rules, a decision service written in business rules. It can be other things as well, like, access to a database or a document store or whatever. But a lot of those problems are now, at first it was not easy, not clear exactly how to do that. Now there's a lot of technology like function calling and structured output, and a lot of things that are being built into LLM frameworks that make all that easier. So there's always technical challenges, and when you're trying to deploy LLMs at scale, there's a big performance challenge. So for example, we have an application we're working on where, there's the user types information into a web page that's hosted by a public administration, and then the LLM has to figure out what's inside the message the user gave, give the information back to the user for validation because we don't want to completely trust that the LLM gets it right every time. So that interaction cycle can only take a few seconds, to be within the acceptable UI window of interactivity. And so there's definitely a scalability problem in using LLMs when you need to make sure that you get an answer back with only 2 seconds. So how do you structure the prompts? What kind of information are you looking for? Where do you put the LLM and how do you call it? And then there's other issues, very, very common that we see around things like privacy and security. Especially here in Europe, there is a big concern about GDPR, about making sure that private customer information stays within the four walls of the enterprise that's processing it. There's a big concern about sovereignty right now. That's kind of, the geopolitical aspect is a big factor in that, obviously. And so, nobody wants to be sending data at this point in the Europe, at least, to servers hosted in the US, and sometimes not even to deal with US companies, to be frank. Uh, so there's all those issues. So you have to figure out, what the right architecture is to make sure you can handle the performance issues, scalability, the privacy issues. Those are all key challenges.
So, Harley, my intuition based on what you've just described is that uh, using RAG is an important piece of that puzzle, but I think it'd be really helpful for our audience if you could explain RAG and how that fits into the framework and supports the performance questions.
Sure. So the the value of RAG, so the reason people are interested in RAG is because when you train an LLM, you stop training at a certain date and time, and it's typically commercial LLMs are trained with more or less publicly available internet data. Let's say it's publicly available, although there's obviously disputes about that.
Right.
Um, but in any case, it certainly doesn't, the training data definitely does not include corporate documents, whether they're financial reports, customer information, internally written reports. There's huge amounts of documents that enterprises manage that could never be part of the training data. And it's very expensive to retrain your own LLM or even to retrain an existing LLM, and that comes with other issues. So RAG is a way to try to bring in relevant chunks of documents into an LLM's context in order to answer specific questions. So the way it works is typically it's like a chatbot. So you ask a question of the chatbot, you try to index or do a search on the query you just gave the chatbot into this big vector database of documents. That should result, using some similarity search techniques, in bringing out chunks of relevant documents that you can then reinsert into the LLM's context, and it provides additional context or information to help the LLM answer the question with all the relevant information. So that's technically how it works. It comes with a bunch of challenges as well, because how well can you find the relevant chunks of documents? How many do you need? Is the similarity search that you're using really going to be adequate for bringing in all the relevant information and so on. So it's a very useful technique in a lot of cases. It's not a definitely not a, magic silver bullet that will, suddenly make LLMs answer every question with the most up-to-date and relevant information, but it's a very helpful technique in a lot of
So
cases.
Harley, one reason I wanted to talk to you, you had a great quote in a webinar, and you just kind of echoed it
Yes.
there, is that I think there's a lot of impression that LLMs came out. Everyone's like, LLMs will just solve everything. Just kind of use it, and it'll solve all our problems. And you've kind of emphasized a couple times, like there's a lot of engineering involved in getting these things up and running.
Yes, that's very true.
Yeah, and I know it's true. Like you're doing mission critical applications, and you know the engineering firsthand, where you just can't make a mistake. Can you set some expectations? Like how long do your clients expect to take, or how long does it take to get one of these systems like up, running, tested, validated, and in production?
The trick with these systems is that because LLMs will always give a plausible answer to practically any question you can throw at them, it's very easy to come up with a very simple demo that looks very exciting and convincing. And if you only need, the 80% solution, the demo usually is very good. Um, in mission critical applications, as you've said a couple times, you can't 80% really isn't good enough. 90% isn't good enough. Often 95 or 98% isn't good enough. You need the right answer all the time. So in terms of just the amount of testing, the amount of integration, figuring out what all the cases are that you really need, and then trying to justify that, there's just a lot of work going from a simple demonstration of the art of the possible to a real deployed system. Now, that said, for without the LLMs, I don't want to my goal is not to denigrate LLMs and tell you they're
Right.
bad. On the contrary, I think they're amazing. So they're fantastic. It's just you have to think about in terms of a complete solution where LLMs are a part of the puzzle. RAG may be a part of the puzzle, so you have to worry about how that's set up. Business rules, optimization, knowledge management, or knowledge graphs might be part of the puzzle, so you have to figure out how that gets put into place, and all of those things have to be engineered together. So you're really talking about a real software engineering project. One thing you can't ask LLMs to do currently, at least, is architect that kind of solution for you. So we still need people's brains for that.
Perfect. Yeah. So how do you, from an engineering point of view, how do you keep up with just the pace of change with the LLMs? Like all of a sudden, overnight, DeepSeek comes out. Now we have
Yeah,
this open source tool that you could have possibly plugged in. Like how do you keep up with that, or how do you think about that?
that's impossible, really. I mean, how can you? Far more information is being produced every day than what a person could read in a lifetime. So you just have to do your best. And I don't think anyone is really keeping up completely with everything that's going on in this field right now. So you have to hope that somebody is doing curation of headlines and that what you read in the news are actually the most important things. I don't think that's always the case, but
Right.
what can you do? I mean,
Do you feel pressure to sort of swap a new LLM model out? Like if you're using, I don't know what you're using, but if you're using OpenAI, do you feel like, well, now I can use DeepSeek, or
well,
now I can use Claude, or do you
yeah,
lock that in, and then sort of go with that for a couple years as the plan?
that just depends on customers. So some customers, for example, have signed an agreement with Microsoft to have a private
Mm.
instance of OpenAI running on their Azure.
Yep.
So okay, we'll go with that. Some
Yep.
customers say, no, we need, have a locally hosted LLM running, and this is what the server configuration looks like, or this is what your VMs we have available. So then you gotta figure out what works, whether it's like Mistral, which is, popular in France, obviously,
Yep. Okay.
French company, um, or something like, R3 now is obviously everyone wants to know whether that's going to work for them. Although, again, geopolitical concerns about working with Chinese company. So
Yep.
all these things that
Okay.
we thought we were past a few years ago are now suddenly important again.
Okay.
So, Harley, it's really the insurance claims processing story that you told us is a really interesting one. I wonder if there's another use case or two that you might share that would shed some light on this for our audience.
Yeah, so my current favorite use case is one that, because something that happened to me. Like a year and a half ago, I was trying to get my French, I live in France, in case that wasn't clear up to now. So I was trying to get my French long-term visa renewed at the local prefecture. And it was their online system for getting meetings didn't, I mean, you couldn't get something for months and months. It would have been, I would have lost my visa would have expired. I don't think I would have been kicked out of the country, but I certainly would have problems with starting my company and, with all sorts of administrative tasks. So I was kind of panicked. I wrote them emails. They never answered my emails. I was tearing my hair out, going on online forums. Everybody's having this problem. Finally, through connections, I managed to get an appointment, but it was a nightmare. And talking with my colleagues, and we decided that if I'm having this problem and everybody's complaining about it, maybe we can offer a solution and maybe AI can help. At a minimum, it probably can't hire more people, but at a minimum, maybe we can understand these emails that are coming in and figure out which ones are really high priority and which ones can be pushed down. So we sent a proposal to the prefectures, to the prefecture, at least where I live. They got excited, and now we're about to deploy it in 4 different prefectures, and we're looking at possibly going national with it as soon as we can. So to me, it's a great approach. We use the LLM to understand what people are trying to say, trying to understand, what the expiry dates are, some of the other key information, like, that you can get out of somebody's message, understand whether somebody's going to lose their job, for example, because they can't get their visa renewed. And then, based on all that, have a set of business rules that basically determine the priority, determine who the right recipient is of the message in the prefecture side, so that the agents, instead of being confronted with a big undifferentiated block of emails that they can't process, at least now the ones that are super critical get highlighted so they can process them first. And that makes a huge difference when, budgets they can't hire more people, but at least the people can be used more efficiently.
It's awesome.
Yeah,
Yeah,
that
you're
was,
relieving a lot of
uh,
pain. Nobody wants to do that research either. It's hard to get to the truth. And you've digitized that with the business rules.
yes. So, and the nice thing about this is that the business rules are used for determining a bunch of different things about how to handle a particular case. But the rules, because one of the cool things about business rules is that you can really handle a lot of variability. And so, in this case, there's rules that are national, like, the rules for how visas need to be handled are national laws. And what are the basic laws associated. But then at the prefecture level, each prefecture has a different workflow, a different back office structure, different set of agents focusing on different things. So each prefecture can also add their own personalized rules to the system that match how they want to do their work and how their workforce availability and specialization. So, again, business rules turned out to be a very valuable construct after processing the initial text, the messages from the customers to get the decisions made appropriately.
Excellent.
Yeah, I guess our final question would be, do you have any books, articles, podcasts, episodes that you'd recommend to our audience to listen to? Anything that gets you excited and helps you learn about the space?
Um, I yeah, gosh, uh, I listen to a ton of podcasts. The TML podcast I like a lot. Um, I listen to Hard Fork just to understand what at least is in the popular what people are thinking about, because that you're going to get questions about that.
Yeah.
Um, and there's a bunch of others, but those are the ones that I listen to every week reliably. Um, and our books, it's very hard these days because all the interesting books are like basic business or technical books, but nobody writes a book anymore that's up to date.
It's almost impossible to write a book that's up
Almost
to date, isn't
impossible. Yeah.
it? You're right.
And yeah,
Exactly. Well, thanks for being a guest. I've learned a lot from this conversation, and thanks for being open to listen to our questions.
Yeah, thanks for sharing, Harley, and best of luck to you and Athena.
Thank you very much, VJ Mike. It's a pleasure, Mike. It's great catching up with you again after all this time. VJ, it's been a pleasure getting to know you too.
Yeah, so I'll look forward to seeing you in Paris sometime soon.
Awesome.
All
All right,
right.
guys.
Thanks.
Thanks for joining us for this episode of the Decision Intelligence Lab podcast. If you got value from our conversation, please like and share. And if you'd like to subscribe directly to the podcast, just send us an email at decisionintelligencepodcast@gmail.com.